All right, math people, welcome back to chapter 7. This is chapter 7, but the first half of this chapter was all two-dimensional geometry. This is our first official 3D geometry lesson where we're going to be doing some computations. With that in mind, all of the stuff that we do from this point on in this chapter, you can use a calculator for. So if you'd like one while you're doing this lesson, grab one now, or you could use the one that's on your computer or phone or whatever. But calculator is totally usable. I'll be using one or explaining how I'd use one throughout this lesson. Today, we're going to be talking about surface area, specifically the surface area of prisms. So first off, what is surface area? You could probably figure it out just by like looking at the words surface area. Surface area is the area of the faces of any three-dimensional figure. So you take a 3D figure, we will be specifically looking at prisms and pyramids in this chapter. In this lesson, only prisms. But yeah, you find the area of the faces in total for any three-dimensional figure. That is the surface area. And in our intro lesson to three-dimensional geometry, we talked about what does it look like when you unfold a figure, a 3D figure. When you unfold a figure, that's known as its net. And being able to draw out the net of a prism will be helpful in finding the surface area of the prism. For example, if you had this rectangular prism here and were to unfold it, so there's the prism itself. If I started to peel it apart, it would look like this. And then if it laid out flat, I color-coded it so you could see the top and the bottom would be those red parts, the sides, and then the back and the front. That's the net, in other words, the two-dimensional representation of this three-dimensional figure. Now, I'll be straight up, I cannot very well create nets. I have a hard time unfolding things in my mind and then drawing that out on paper. So I'll be showing you an alternative. If you can draw the net perfectly, do it. I struggle with it a bit, and I'll show you who might not be visual learners like me how to do this without doing the net. So first question says, find the surface area of this rectangular prism. If you can draw the net, woohoo! I cannot come up with this net on my own very well. So while this is the net, and I'll leave it there for a moment so you can see it, I would say step one is draw what I call a deconstructed net. Meaning, in front of us is a rectangular prism. I know that a rectangular prism has 6 rectangular faces. I'm going to draw this net, but it's not going to be all connected. I'm just going to draw the net in groups. Like, for example, this is color-coded. The front rectangle is a 7x3 rectangle. So I'm going to draw that. This is the front, and it's also the back. If you could see straight through this prism, the back would be a matching 7x3 rectangle. So there's 2 of these. So I'm going to circle that. That's 2 of the sides, the front and the back. On the left and the right side of this figure are the blue rectangles that look like this. One part of that rectangle is 4 inches, and the other part is the 3 inches that's going from top to bottom. That's 3. I'm going to call this the sides. So side 1 and side 2, side. So there's 2 4x3 rectangles. And then the last is the top and the bottom of this prism. It's red, and it's 7 inches across, and it's 4 inches from back to front. So this will be a 7x4, and I'll call this the top and the bottom. There's nothing wrong with doing your net like this, meaning drawing it in chunks, deconstructing it. Now that I've got the net, all of the sides drawn out, I can find the surface area. So step 2, find surface area. This is so easy because we just came off of a 2-dimensional geometry unit. 3-dimensional geometry, surface area is not hard at all. What we're going to do is we're going to find the area of this figure, then we're going to find the area of this figure, and then the area of this figure, and just add it all together. Super duper easy. So the front and the back, which I'm calling F/B, front back, is 7 times 3. But that's for one rectangle. There's a front and a back, so I need to double that. 7 times 3 times 2 is 42. All right, that's 2 sides, so I'm going to call this side slash side. Is a 4 by 3 rectangle, and there's 2 sides. That would be 24. And then the top and the bottom are 7 by 4 rectangles, and there's 2 of them, and that would be 56. So altogether, the total surface area, which I'll write very clearly on the side, total surface area equals the sum of all of these things. So 122. And our units for this is going to be inches squared. And you might be thinking to yourself, whoa, wait a second. This is 3-dimensional geometry. Why do I have inches squared? That's for flat figures. We laid this figure out flat. So that means that this is going to be inches squared. It's regular area. This is not a 3-dimensional thing that we found. We found a 2-dimensional area, inches squared. And that's your first problem. To try to keep this lesson not super long, I'm not going to do another example of a rectangular prism. We're going to jump right into the surface area of a triangular prism. It's the same concept. You're going to need to be able to either mentally do this, unfold the triangular prism, and turn it into the net. I have a hard time doing that. So I'm going to deconstruct it. But just so you can see it, there's our triangular prism, there's the unfolding process, and then this right here is the net, totally laid out flat. But let's try this on an actual triangular prism. So I'm going to show you the net. Here's the beginning prism, here's the net of that prism if you unfolded it. I'm not even going to look at that personally, I'm going to deconstruct it. So step 1. Let's see. I know that this triangular prism has a base that's a triangle, and there's 2 of them, the green triangle in the front and the green triangle in the back. And this triangle has a base of 12 and a height of 5, which I just traced out, 12 by 5. So 12 by 5. And this is, I'll put the bases. 2 of them, plural. All right, the bases. Then we have the yellow rectangle that's kind of on the back side here. So I'll put rectangle 1. Rectangle 1 is an 8 by 5 rectangle. And then there's 2 more rectangles. One is hard to see. It's laying flat on the bottom here. I'm tracing it out in black. And that rectangle, which I'll call rectangle 2, is 12 centimeters by 8 centimeters. Last rectangle, rectangle 3, is this blue, looks kind of like a slide that's slanted downwards. So rectangle 3, the blue one, is 13 inches by 8 inches. If this is 8, then the top of this is 8, so it's 13 by 8. 13 by 8. And that should cover all of the sides. There's 3 rectangles and 2 triangles. So my surface area is going to be the area of all of these figures combined together. For the triangles, that'd be 12 times 5 times 1/2. That's for one triangle, and we have to double that because there's two triangles. Plus, there's this one 8 by 5 rectangle, plus there's this one 12 by 8 rectangle, plus this 13 by 8 rectangle. When you add all of that together, that gives you your total surface area. Since you're going to be using, I hope, a calculator to do this, um, this is the work you need to show. You don't, I'll be detailed about it. You don't have to then do this. At least I don't feel like you need to, because the calculator can handle doing all of this. But if you want to write it all out and be thorough, be my guest. So this would be 104 plus 96 is 200, plus another 100 here is 300. So the surface area, I'll label this total surface area equals 300 square centimeters. But yeah, this line right here, this is how you show your work. I would also super strongly encourage everyone to be doing this. Either draw the net or the deconstructed net and label it clearly, just like I did, and then just jump right down to your final answer. Let the calculator do all the heavy lifting of multiplying and adding it all together, and that's your total surface area. And that's your mini lesson on how to find surface area and what surface area is. We'll work on this tomorrow in class a whole lot more. For now, I'm going to give you one question to try on your own. That will pop up on the screen now. And once it does, take your time to write it all out on a piece of paper, find your surface area, and then type in your final answer, and then bring that with you to class tomorrow, and we'll build off of that. All right, you saw your question. Hopefully you gave it a try, answered it. If you have any questions beyond that, let me know now. Otherwise, have a fantastic rest of your day. See ya.